Once we have our schedule management plan, activity list, activity attributes, and milestone list, we will begin sequencing activities. In this process, we create relationship between activities to obtain more efficiency in the project. So this process could be done using a software that could be Primavera P6 most common, and any other software. We can do it manual as well, and we can use a blended approach, like some activities we can do on a software and some we can do manual. So as an input, we will have project management plan, schedule management plan, and scope baseline, project documents, activity attributes, activity list, assumption log, milestone list, EEF, and OPA. Tool and techniques are precedence diagramming method, dependency determination and integration, leads and lags, project management information system. As an output, we will have project schedule network diagram and project document updates. Activity attributes will be updated, activity list, assumption log, milestone list. Precedence diagramming method. In this process, activities are represented by nodes graphically connected in sequence with logics. So we can use four types of logics: finish to start, this is most common; start to start, finish to finish, and start to finish. Start to finish is rarely used. There are four types of relationships in precedence diagramming method. The first and most commonly used is finish to start. Like here we have two activities: activity A, that is a predecessor; activity B, that is a successor. In this type of relation, activity B cannot start until activity A is finished. So as an example, say you need to install a TV at your home. So you have two activities: activity A, you need to procure it; B, you need to install it. So you cannot install it until you have procured it. So this type of relationship is called finish to start. This is most commonly used in precedence diagramming method. The next one is start to start. So typically this type of relationship is used with a lag time. Like for example, we start activity A, then after some time, like after a day 1, 2, 3, we start activity B. As an example, say you have 100 of pipes you need to paint. So you need to do double coat, first primer coat and then top coat. So what you will do, like initially we start doing first coat on the first 5 pipes. We don't have to complete all 100 pipes before we start second coat. So after 1 day or 2 days, once our first coat is cured, we can start using top coat. So this type of relationship is called start to start. So we can do both the activities, predecessor and successor, parallel. So okay, next is finish to finish. In this type of relationship, a predecessor activity cannot finish until a successor activity is completed. So this type of relationship, say you need to submit documents and to a new project you have been awarded with. So to complete those documentation, you can some documents you can do internally, and you need one inspection company, they have to provide you with a letter. So your documentation cannot be completed until you have that letter from that inspection company. So this type of relationship is finish to finish. Like, oh, your first activity, a predecessor like documentation, cannot finish until you have that letter from that organization you are waiting for. Then you can submit your documents. So this type of relationship is finish to finish. The last one is start to finish. This is most rarely used. As PMI also explained, this is for scheduling experts. This type of relationship where a predecessor activity cannot finish until a successor activity has started. So as an example, a new account payable system successor has to start before the old accounts payable system can be shut down. So this type of relationship is called start to finish. So this is very rarely used for and also for scheduling experts. Dependency, determination, and integration. So we have four types of dependencies. The first one is mandatory, discretionary, external, and internal. So what is mandatory dependency? This type of dependency is also called hard logic that we must follow by nature. We cannot start a next activity until we have completed that set of work that is required to start that activity. So this type of activity is called mandatory activity. Like we cannot start using our installation process until our procurement is completed. Like we have to have that material before we start installation of that. So this type of logic, this type of dependency is called mandatory dependency. Like we have limitations that we have to follow. Discretionary dependency is also called soft logic. So this type of dependency is where we can use this dependency on preference basis. Like we can do that or we can do this activity. So this depends on our best practice. Like for example, we are doing MEP project. So this is in our hand. We will decide before we will do electrical work or we will do plumbing work. So this is there is no limitation. We can also do electrical work first and then plumbing work, or we can do plumbing work first and then electrical work. So this type of dependencies, discretionary dependencies, also called soft logic. External dependencies. External dependencies, we have an external constraint, like we are procuring some material that is coming from China. So that is not in our hand. We have to wait until the material arrives. So this type of dependency is called external dependency. Or we are waiting for a permission from a government authority, so we cannot start that work until we have that paper in our hand. So this type of dependency is external dependency. Sometimes this is not in project team's hand. Those types of dependencies are called external constraints, because we cannot start that work without that activity or without that constraint, and also that constraint is out of project team's hand. So this type of relationship is external dependencies. External, simply you can remember external, so it's not in project team's hand. Internal dependencies. So internal dependencies also is a kind of hard logic, and but the difference between external and internal is internal dependencies are within project team's hand or within the organization. Like we have some resources that are being used by this organization on a different project, and we also need to use that resources or that specific resource. So we are waiting for that resource to be free from the other project so we can use it. So this type of dependency is within the organization. So this is within the organization's team or project's teams in hand. This type of dependency is called internal dependency. So this is within project, but also this is a type of hard logic. We cannot skip that and move to our next activity or our next process. We have to have that resource before we move forward. So this type of dependencies are called internal dependencies. About leads and lags. So what is leads and lag? This is mostly used in when we are scheduling our project. So we use leads. Leads is amount of time a successor activity can be advanced from predecessor activity. For example, we have an activity A that is a predecessor, activity B is a successor. So we create a relationship that activity A will finish, activity B will start. But we give a 3 days lead time so that before activity A completed, like activity B will start. 3 days before activity A complete, we start activity B. And lag is a amount of time a successor activity can be delayed from its predecessor activity. So we have a predecessor activity and we have a successor activity. So predecessor activity and successor activity will start together with a 5 days difference. So this is the same example. We have to paint our walls, like we have 10 walls we need to paint double coat. So we cannot wait until we finish all the wall with a single coat and then we start second coat. So we can, what we can do, for the first 5 days we do complete one wall, and after 5 days we will start using second coat, and also we will keep doing first coat on the remaining wall. We delay a successor activity for 5 days, but they start together with a 5 days difference. So this is lag. And lead is, say we have two equipments to install. Installation of first equipment is activity A, installation of second equipment is activity B. So we cannot start installation of second equipment until we have installed our first equipment. But we cannot wait our first equipment to complete 100% before we start our next equipment installation process. So in this case, what we do, we create a relationship finish to start with a 3 days lead time. So in this case, what happens, like we are installing our equipment activity A. Before we complete like 3 days, we will start installation of our second unit. So this type of relationship is used finish to start with a 3 days lead time. I hope you understand. Project management information system is also a tool and technique we use in this process to schedule, sequence our activities. So we discussed precedence diagramming method as a tool and technique, dependency determination and integration, leads and lags, and project management information system. So we can sequence our activities, and four types of relationships we use: finish to start to start, finish to finish, and start to finish. Also we have four types of dependencies: mandatory dependencies, discretion dependencies, external dependencies, and internal dependencies. And we have leads and lags. So once we do all this using all these tools and techniques, we have our schedule network diagram ready. Let's talk about schedule network diagram. Schedule network diagram is a diagram where we can see all set of activities with the relationship, lead time, and lag time. So here is a set of 10 activities: A, B, C, D, E, F, G, H, I, J. Start and finish. So what happens? We have activity A, and activity A has two successors, activity B and activity C. Activity B has two successors, activity D and activity F. Activity D has one successor, that is activity E. Activity F has activity G as a successor. Activity C has one successor, activity H has one successor, activity J has one successor. So once we complete our activity A, we can start activity B and activity C. Once we complete activity C, we can move to activity H and activity I after completing H activity. So in this case, you can see that E is a successor activity and D is a predecessor activity, and B is a predecessor of D and F. A is a predecessor to B. As you can see, activity C and J, they have a relationship of start to start with a 5 days lag time. Like we will start activity C and activity J together with a 5 days difference. Also, there are two activities, activity F and activity G. They both have a relationship of finish to start. So we will finish activity F and we will start activity G. But before we finish, we will not wait until activity F complete 100%. 2 days before completion, we begin activity G. So, date. So this network will help us to understand about successor, predecessor activities, lead and lag time, their relationship. So all these, as we discussed in sequence activities. So in a schedule network diagram, we will have all possible detail about our network diagram. From here, we can understand when once we will complete our estimate activity duration process, we will know that like a network A, B, D, E, how long it will take. Once we have a duration, we will know that this path is taking how long. So this network will help us create a critical path, understand it and manage it later during develop schedule and control schedule process. So this is a schedule network diagram as an output. Also as an output, we have project document updates like activity attributes document will update, activity list will update, assumption log, milestone. So all these documents will be updated once we use all these tools and techniques and we create a sequence between activities. We have finally project schedule network diagram and project document updates. Estimate activity duration. In this process, we calculate how long an activity will take to complete. So as an input, we have project management plan, two plans, schedule management plan, scope baseline, project documents. We need activity attributes, activity list, assumption log, lesson learned, milestone list, project team assignments, resource breakdown structure, resource calendars, resource requirements, risk register, EEF and OPA. Tools and techniques. We need expert judgment. We seek experts to give their inputs regarding the estimation of activity duration. We use other techniques, analogous technique, parametric technique, 3-point estimation, bottom-up techniques, data analysis, alternative analysis and reserve analysis, decision making and meetings. We'll talk about these tools and techniques in this video. And as an output, we will have duration estimates, basis of estimates, project document updates, activity attributes will be updated, register, assumption log, lesson learned, register. Estimate activity duration gives us predictable time that we require to complete an activity or a project. Before we begin, we need to understand few things. Law of diminishing return. So as per this law, basically we can get only so much return when one factor is constant. So for example, if one activity requires 6 hours to complete, we cannot do it in 3 hours by adding 2 people. For example, we need to make a joint between 2 pipes. So for that you need 1 welder. So by adding 2 welders, it's not possible to do it in half time. So this is just an example. So by this point, we cannot keep adding labor to do that activity in less time. So there is some time that is required to complete that activity. We have to have that time. So that is law of diminishing return. Like if one factor is constant, we cannot keep adding labor to do that activity in less time. Number of resources. So doubling the resources, we cannot get double output. So if we have one operator, he can operate only one machine, so we cannot let him operate two machines. So this is number of resources. So we cannot get more productivity by adding extra resources. However, advance in technology, if we use advanced technology, we can increase our production. But in that case, we have to consider that learning curve. When we add new technology, we need some time to learn. So the project team takes some time to learn that technology, then production will increase. So by adding extra resources doesn't mean we will get more productivity. Advance in technology, we can have more productivity by using latest technology. So motivation of staff, like there are two concepts, student syndrome and Parkinson law. So they are basically same. Student syndrome, I will tell you month. So if you have scheduled your exam after 6 months, so your productivity in the first month will not be same as the last month. So basically what happens, we wait for the last moment to start preparation, like the best possible time we can take to start that activity. So we have to consider this factor. Parkinson law is also same. Like for example, we have an activity that will be completed in 10 days and we have 1 month time. So as per our psychology, we will keep dragging it until the last possible time reach, and then we will start doing that activity. So this is Parkinson law. Analogous estimating is basically we estimate an activity using historical data. So this process is not very costly, not time consuming, but this is also less accurate. So we can use this technique for all the activities, or we can use for some activities, and we can use other processes for other activities. So basically, analogous estimating is using historical data. For example, we have done the same activity in our previous project, so we refer to that project. Like last time it took 10 hours, so we consider duration 10 hours. Another approach we use is parametric estimating. In this approach, we have a parameter to use to calculate the total quantity, like time per unit, square footage, and also we use historical data. For example, we have to concrete 100 cubic meter. So first we will calculate for 1 cubic meter, and then we will multiply with 100 and we will get for the total. So how long it will take to complete 100 cubic meter of concrete. So this type of approach we use for good results. So parametric estimating approach is more accurate and reliable. So as an example, say we required number of hours to complete one unit multiplied by total number of units. We need 8 hours to install one unit and we have total 150 units to install. So we can simply multiply 8 with 150. So we require 1200 hours to complete all 150 units. Another technique we use is 3-point estimating, where we consider most likely, optimistic best case scenario, and pessimistic worst case scenario. And we use triangular distribution, like we take average of best case scenario, worst case scenario, and normal duration, and we also use beta distribution. Say using triangular distribution, triangular is average of 3, most likely, optimistic, and pessimistic. So T is used for the time, TO plus optimistic time, most likely time, and pessimistic time. So say we have an activity that takes 25 days in normal situation. However, we can complete in 20 days, best case scenario, if everything is in our favor. And it may take another 5 days in worst case scenario, like if something happens that is not in our control, so it can take another 5 days. How we can estimate duration for this activity? Like we take average of all three scenarios, 20 plus 25 plus 30, and average with three factors, so it will become 25 days. So we will consider 25 days as normal duration to complete this activity. Let's talk about PERT. What is PERT? PERT is Program Evaluation and Review Technique. This is also called beta distribution. In this situation, if we have more chances of normal situation, so we use beta distribution. In this situation, we take 4 times weightage of most commonly used and less weightage of optimistic and pessimistic situation. So the formula will be optimistic time plus 4 times most likely plus pessimistic time divided by 6. Say we have an activity that will take 10 days in normal situation, and if things are in our favor, we may complete it in 8 days, and if something happens wrong, this might take 2 additional days. So we will take it as 8 plus 4 multiplied by 10 plus 12 divided by 6. So we will consider 10 days. So if we use PERT technique, our answer will be more toward our most likely duration that we have entered. So if we use 3-point estimation, it will be an average. So PERT technique we use if we want our answer to be more toward most likely parameter. So let's do an exercise. We have an activity that will take 35 days most likely, and optimistic duration is 16 days, pessimistic duration is 52 days. So we will use triangular distribution. We will take average for all these three parameters, 16 plus 35 plus 52, and our answer will be 34.33 days duration required for this activity to complete. So if we use PERT technique, we will use 16 plus 4 times most likely plus 52 divided by 6, and we will get 34.66. So here you noticed 34.66 is more close toward our most likely duration. So we will use PERT technique if we want our answer more toward our most likely parameter. So this is where we use PERT technique. So in this technique, we estimate duration by decomposing the project component into the smaller activities, and we start estimating activity duration from the lower activity, from the bottom side. Like we will start estimating from our smallest activity, and we will aggregate it into a total for the complete duration. So this technique is also used for estimating activity duration. So as an output of this process, we have duration estimates, basis of estimates, project document updates, assumption log. What is duration estimates? We get duration estimates, total duration of a project or phase with a range of possible results. Like we have estimated our activities using different techniques: 3-point estimating, parametric or triangular beta distribution, bottom up technique, analogous technique. So we sum up duration of all the activities and we come up with the total duration of a project or phase with a possible range. Like total duration of the project is 10 weeks with plus minus 1 week. Like we can complete this project 1 week early, or in worst case scenario we will be delayed only by 1 week. Basis of estimate: we need to support our estimation. We need to provide basis, like on what basis we have done this estimation. So we have to document basis of estimates. Plus we have documents update, activity attributes, so where we have all the detail related to activity relationship, their predecessor. So all those details will be updated as an output of this process. So we have assumption logs, we have lesson learned register, so all those documents will be updated.